So the purpose of this video is to show how to do a normal probability distribution using the graphing calculator. Okay, so you should be able to see on my screen here, I've got a couple questions, right? So recently, I've been curious as to how my calculus students have scored on the final exam. From a study of 350 scores from the last 7 years, I have found that the mean score is 73 with a standard deviation of 8. So I've got a mean of 73, right? My standard deviation is 8, mu is 73, sigma is 8. Suppose the score is selected at random. What's the probability that the score is between 73 and 85? Okay, so what's the probability that 73 is less than X is less than 85? What's the probability that the score I select at random is between a 73 and 85? So what I'm going to do on the graphing calculator, we've used second vars or second distribution. We use this same button to go down to option A and B for normal binomial PDF and binomial CDF. We're going to go back to second distribution here, and we're going to look at normal PDF and normal CDF. We're going to use the normal CDF. Normal cumulative probability distribution function, normal cumulative distribution function. We're going to put the lower end of the range, which is in this case 73. The upper end of the range is 85. We need to enter our mu, our mean, I said was a 73, and the standard deviation for these tests was an 8. So if I simply now click paste, normal CDF from a low of 73 to a high of 85, given that we had a mean of 73 and a standard deviation of 8, we press enter, and we find that that probability is 0.4332. I'll go 4 decimal places. Okay, so for the next one, what's the probability that X is between 70 and 80? I'm going to do that problem the same way. Okay, I'm going to go back to the same place. Second distribution, number 2, normal CDF. Now my lower end is 70 and my upper end is 80. I still have a mean of 73 and a standard deviation of 8, so I don't need to change those. I select paste and press enter, and I found that this probability is 0.4554. So the probability that I randomly select a student and their score is between a 70 and an 80 is 0.4554. That tells me, by the way, that 45.54% of the scores are between a 70 and an 80. Okay. Now, the last two here are interesting. Find the probability that X is greater than 85. Okay, if I want to find the probability that X is greater than 85, second distribution, again, normal CDF. If I want to find the probability that the score is greater than 85, 85 is my lower end of the range, but my upper end, notice that this is a one-sided confidence interval. There is no upper end. So the rule here for the upper end is that it needs to be extremely higher than the mean. Okay, we've talked in class about the number of standard deviations. Once you get past 3, 4 standard deviations, the amount of data that's out there is just really, really, really small. So here's the rule. The upper end here, since it's about an unbounded side of the confidence interval, the upper end, not the confidence interval, but the range here, the upper needs to be at least 4 standard deviations greater than the mean. So at some point, a lot of people take out their calculator and say, okay, or I can do it right in here, right? So my mean is 73. Plus 4 times 8. So my upper bound needs to be at least, the calculator's not going to do it there. 4 times 8 is 32. 32 plus 73 is 105. So the upper range needs to be at least 105. Okay? Now, suppose I make this 105, and I press paste, and we calculate this, and notice that our probability, and this time I'm going to put in all the decimals for now, 0.06677555427. I'm going to go back to the calculator. Now suppose I said, because this is how I tend to do the math, I need to do 8 times 4. That's like 100. Plus 85. That's like 500. So that's ridiculously higher than it needs to be because I can't make it too bigger. Great grammar there, right? Notice that my decimal is greater. Actually, 0.066807 is a better approximation because that 500 is even farther from the 73 than is the 105. In fact, what if I just made this 1,000 or 10,000? Okay, is that going to make it bad? Is it going to make it worse? Notice that there's actually no change in that up to 10 decimal places out. So you can't make a mistake putting that one end that's unbounded. You cannot make a mistake by making that too big. Okay, the mistake you would make would be if you made it actually too close to the mean. Okay, so let's try this with score. What's the probability that the score is less than 70? That's the probability that x is less than 70. So when I go back to the calculator, second distribution 2, now this time it's my lower end that's unbounded. And some people have it in their head that, oh, what's the smallest number possible? 0. No, 0 is not the smallest number possible. Let's make my lower end a negative, using the negative button, not the minus, 1,000. And then the upper end, we're going from negative infinity, right, from negative 1,000 up to 70 with a mean of 73 and a standard deviation of 8. We select paste. And so the probability that the score is less than 70 is 0.3538. Okay, so just a quick excursion into how to do normal CDF in the graphing calculator. I'm going to tack this on at the end of this video. I will mention this in class, and every time I talk about it, you notice that the normal PDF is there. That's really kind of doesn't make a whole lot of sense to say what's the probability that x is exactly 73. Okay, I never use this, and I don't want you to use this because really that normal PDF that it's exactly 73, it doesn't happen. It can't be exactly 73. So we're just not going to use, oh, I'm sorry, I did that wrong. We're still going to not use the normal, I forgot to change this, right, with a mean of 73 and a standard deviation of 8. Okay, we're not going to use that. What we're going to get here is 0.04986. Well, let me try something else. If I compare 72.5 to 73.5 with a mean of 73 and a standard deviation of 8, see, I get the 0.0498. What the calculator is doing, when you say what's the probability of getting 73, it's actually finding the range from 72.5 to 73.5. If I want that range, I'm just going to use normal CDF, and I wouldn't bother to use the PDF. So it kind of like is a bit of a misnomer there. So anyway, there's a little look into using the graphing calculator to calculate normal probabilities.